Hi, I'm Steve Wireman, and today I'm going to talk about primitive data types and mathematical operations in Java. This is the third video in a series on getting started programming with Java. For more information, visit my website, www.iteran.com. So let's just jump right in. In programming, we have what are called variables. And if you've done programming before, you know what these are. If you haven't, variables are just named locations in memory that we need for storing data. So let's say we're writing a payroll management application, and we'll do this as a very simple example today. So we might have variables like employee, and then the value, in this case it's a string. We might have hourly rate and a value, might have hours worked per week, and number of weeks. And we'll come back to that example in a little bit. In Java, we have what are called primitive data types, and you find these in most modern languages. Primitive data types are, unlike objects, just the very simple, basic data types that we use to store data. Unlike objects, they do not have methods associated with them. They're just data stored in memory. So our 8 data types in Java are byte, which is an 8-bit integer. It's a signed integer, so it has the range between negative 128 and positive 127. We have a short, which is a 16-bit integer. We've got int, which is a 32-bit integer. And we've got long, which is a 64-bit integer. And unless you're doing some highfalutin mathematical operations, you can get by with those 4 integer representations. 64-bit integer, to give you an idea, that goes up to a 19-digit number. For most of the examples we do, we'll be using int. We also have floating point numbers. These are also, of course, signed numbers. We've got float, which is a 32-bit number, and double, which is a 64-bit number. And if you're using something that requires floating point arithmetic, then you're probably going to want to use double, because it's going to give you better precision. We have Boolean, which is just a Boolean true-false value. And we've got char, which is just a 16-bit Unicode character. So you'll notice that string is not up here. That's because string is not a primitive data type. String is actually a class. So when we create strings, what we're creating are string objects. And we'll come back to string later. So declaring variables. Variables in Java, Java is a statically typed language. So that means we have to declare the variable that we're going to use before we use it, and we have to specify what type it is before we can use the variable. This is different from if you have experience with languages like Python. Python is duck typed, which means you can just use a variable, throw out a name, assign it a value, and the interpreter will be able to figure out what type it is. We don't have that with Java. We have to specify what type we're working with and what the name is before we can actually assign it a value. And we'll see some examples of how we do that in a moment. I wanted to talk about mathematical operators. We've got these very basic operators that are the same in virtually every modern programming language. You've got the equals, which is an assignment operator. You've got addition, subtraction, multiplication, division, and you've got the remainder operator. It's an important operator if you're working with integer arithmetic. If you divide 2 integer numbers in Java and in a lot of other modern programming languages, it's going to return an integer. So that means if we do something like 3 divided by 2, if we're talking about just integers, that's going to give us 1 and not 1 1/2 or 1.5, because it's saying the compiler will see an integer, another integer. Okay, I need to return an integer. Well, what's the remainder? Well, that's what we have this percent, this remainder operator. It's also known as the modulus operator. So as an example of how you declare and assign values to types or to variables, we can declare double hourly rate, and we set that equal to a value. We can set things equal to values in the declaration immediately after we declared it, just like those, or we can set them equal to values at some point after the declaration. So you see we've set hourly rate to $20.75, we set the hours worked to 40, and then I have this variable weekly pay, and weekly pay is just the hourly rate times the hours worked. We also have shortcut operators. Now, shortcut operators allow us to type things a lot shorter than what we would need to type if we were to type it out the long way. We've got the increment and decrement operators, which add 1 and subtract 1 from whatever we're operating on. We've got plus equals, minus equals, times equals, divided by equals, and remainder equals. And what those do is that they perform the operation using the two values, and then they store that value in the left-hand side variable. So x plus equals 5 is the same thing as x equals x plus 5. This is not algebra. We're actually changing the value in x. There's already some value in x. Say it's 3. If you run this operation, x will now have 8. Increment, decrement operators. Those two operators can be prefixed or postfixed. So you could do x plus plus or plus plus x. And in the context of what I said in the previous slide, it's going to do the same thing, but the behavior of those two things are slightly different, and we'll talk about that a little bit later. I don't want to go into that just yet. Right now, what I want to do is bring up NetBeans, and let's create a simple payroll application. So I'm going to create a new project, new Java application. I'll call this payroll example. And again, I'm going to change my main class, the package name, to com.iterand.payrollexample, and just click finish. So that creates payrollexample.java, and I don't care about the other features. I'm just going to maximize this part of the editor. So what I did was I double-clicked on the payrollexample.java tag right there, and it maximized that window. If I want to unmaximize it, I can double-click on it again. So let me get rid of the comments. Right now, we don't care about those. Like I said, I'll talk about them in a later lecture. So let's create a string, and we'll say that our employee's name, like on the slide, is John Smith. Let's create a double for hourly rate, and that's going to be $20.75. Let's create an int for hours worked per week, and we're going to say that that's going to be 40 hours. Let's create a int for the number of weeks worked. Now in Java, you cannot have spaces and certain special characters appear inside your variable names. The common convention is to have to use what are called camel caps. So the first character of variable names, of objects, and of method names for that matter, those are all going to be lowercase, and then every subsequent word, instead of putting a space, you're just going to capitalize that word. So hours worked per week, the W, the P, and the second W all get capitalized. So we've got those variables set up. Let's create a variable for the amount to pay, double, we'll call this pay amount, and we're not going to assign any value to that just yet. Now let's actually print some of this information out to the console so we can see that the program is actually doing something. So what we'll do is we'll do system.out.println, and we'll just type in employee, and we'll just put a single space there. So type that exactly as I typed it there. Oh, let's also actually put the employee name there. So what this will do is, instead of printing out the word employee, it's going to print out the value that's stored in our variable employee. So that will put John Smith in that spot when we go to run this program. And let's print out the hourly rate. Same sort of convention here. The plus sign that I'm putting here isn't a mathematical operation because we have this string here and the string here. What it's doing is concatenation. So it's going to take the value that gets printed there and just print it out. It's going to tack it onto the end of that string and print out that entire string. And then let's print out the next thing. Hours per week. Number of weeks. And then finally, let's compute the pay amount. So pay amount is going to be equal to the hourly rate, helps if I spell it correctly, times hours worked per week times number of weeks worked. Now let's print out that value. The amount to pay will be pay amount. Now if we typed everything correctly, and let me unmaximize this so we can see the output window there. So if we typed everything correctly, our output should appear there, and it should print out all those values correctly. And it does. Now you'll notice a few things here. We're talking about money. There's no dollar sign. Here, when it actually computed the value, it did not give us 2 zeros. There's a way to fix those things. We're not going to go into that today, but we will visit that at a future mini lecture. So I hope you found this useful, and check back soon for the next video.